Greetings of the day, students. Today we are going to deal with the concepts of parallel algorithm. The topics are nothing but introduction of parallel algorithms, components of parallel algorithms, and PRAM models. Okay, so before going to the topic, we must know what are the concepts of the parallel algorithm, why we have to discuss about parallel algorithms, what are their importance, such kind of basic things. If we are going to get familiar, it would be easy for us to understand the concepts of the parallel algorithm. So let's start by giving a real-time analogy or the importance of the parallel algorithm. For suppose there is a huge pile of sand. Okay, there is a huge pile of sand, and one person is going to shift that sand in a basket from one place to another place. So it takes for him at least 2 days, for suppose. Okay, at the same time, if we observe the concept, the same scenario, if we observe the same scenario by considering 5 persons, okay, with their own baskets, and they are also shifting the sand from the same place to another place. So what do we observe in this kind of scenario? That the second case, the task is completed very fast. Okay, in the second case the task is completed very fast. Okay, so why we are saying that the task is completed very fast? Because there are more persons, okay, and everyone is having their own things to complete the task. So in a same scenario, if we compare that only one person is there, we can call that one as a sequential algorithm. That means in a scenario where multiple tasks are there and we have to wait until one task is completed, the other task to be carried out. Okay, so that is the first case. If we compare the second case, what do we observe? In the second case, every person is having their own baskets. So that means what, we are having a number of processors there, and each processor is given their own task. Okay, so here when we execute these tasks parallelly, we can expect to get the output very fast compared with that of the first concept. Okay, so here in parallel algorithms, what we observe is that a task is divided. Okay, the given task is divided into multiple small tasks. Okay, and each task is given to one processor. So that's why if we observe the real time scenario, it would be very easy understandable for us the importance of the parallel algorithms. Okay, so to get a knowledge of the parallel algorithms, what we should know in before. Okay, so every person should have a prior knowledge of algorithms and data structures. Okay, so algorithms, how to define an algorithm? An algorithm is nothing but a step by step process to solve a given problem. Okay, problem is given to us. So how to solve that problem? There are certain steps. Okay, and ordered steps. Okay, so we can term that one as a algorithm. Okay, so the step by step execution of a process, okay, that could be represented in the form of an algorithm. When we talk about the algorithm, so here as we have discussed in the real time analogy, we are having two kinds of algorithm. What are they? One is sequential algorithm, another one is parallel algorithm. In sequential algorithm, there is only one processor. Okay, in parallel algorithm there are many processors. So if you look at the diagram, so there is a problem. Okay, so here we are dividing the problem into several number of tasks. Okay, in the sequential algorithm, if we observe, there is only one processor. Okay, you cannot move to second task before completion of the first task. So it takes a bit of time for us to complete all the subdivided tasks. Okay, now consider the same scenario, how it could be processed in a parallel algorithm. Okay, so if we look at the diagram of the parallel algorithm, so here what do we observe? The given problem is divided into number of tasks, and each task is given to a processor. Okay, so what do we observe here in terms of the parallel algorithms? Though the subtasks are given to different processor, so due to which what happens, parallel execution of the task is going to be carried out. We can expect the result of such kind of huge complex problem in a very short time. So there are certain advantages if you are going with the concept of the parallel algorithm. So that's the basic difference between sequential algorithm concept and parallel algorithms. So hope that the idea of the sequential algorithm and parallel algorithm is more clear with the real time scenario. So here what are the principles of the parallel algorithm design? As we have discussed now, so there is a huge problem. Okay, problem is given to us, and that is divided into certain subtasks, and each task is given to a processor. Okay, so if we observe this kind of scenario, so there there are number of tasks. Okay, a huge problem is divided into number of tasks. Okay, and there is a relation among the tasks. Okay, so that means if T1 is not completed, then T2 has to wait, and T3 is not completed, T4 has to wait, like that. Okay, so if we observe that a problem is divided into 4 tasks such as T1, T2, T3, T4, and this is the relationship among them. Okay, so these tasks are being dependent, and what do we observe? Task T1 is related to T3, T1 is related to T4, T1 is related to T2, again T2 is related to T4. That means what, until T1 is going to be completed, T2 has to wait a bit. So there is a dependency among these tasks which need to be completed. Okay, and they are connected with a graph. So these such kind of scenario we represent and term that one as dependency graph. Why we are calling that one as dependency? Because the huge problem is divided into certain subtasks, and each task is dependent on another. Okay, and the graph that we are getting by connecting all such kind of subtasks are nothing but termed as a dependency graph. Okay, so this is one of the main principle in order to achieve or how to carry out the concept of the parallel algorithm. Okay, the parallel algorithm design initiates that the given problem should be divided into subtasks, and there is a dependency among these tasks. Okay, so when we connect these tasks, we get a graph. That's why we term these graphs as dependency graph. Okay, for in order to understand the problem further more clear, now consider a small example. For adding 8 numbers, okay, we start with 4 processors. Okay, so let's consider we are taking 4 processor P1, P2, P3, P4, and each processor adds 2 items in the first step. So this is the first step. Okay, and these are the numbers which are given to us. If we are going to have a look here, so P1, P2, P3, P4 are the 4 processor. What are the numbers that are given to us? 5, 3 that are added by the processor P1, minus 6, 2 that are added by the processor P2, 2 and 10, 7 and 10 that are added by the processor P3, and minus 2, 8. These numbers are added by the processor P4. So here large that means a group of numbers are given. We are dividing these numbers into a pair and giving the addition of the task to one processor. Okay, so now the addition of 5, 3 that is nothing but it becomes 8, the addition of minus 6, 2 that becomes minus 4, the addition of 7, 10 that becomes 17, the addition of minus 2, 8 that becomes 6. Again we are getting 2 more numbers. Okay, so again we have to add these 2 numbers that is given as a task to another processor, that is P1. Similarly here also P3. So 8 minus 4, so the result is 4. 17, 6, the result is 23. Again we are getting 2 numbers, 4, 23. So here we are having 2 numbers. So again that is given to one processor. So at last we are getting 27. So for the given group of numbers which we need to find the sum, 5, 3 minus 6, 2, 7, 10 minus 2, 8, we are forming dividing that one as a subtask, and each subtask is given to one processor, as we have said. Hope that the example is very clear to us. Okay, now so approaches that need to develop the parallel algorithm. So detect and exploit the inherent parallelism available in the existing sequential algorithm. Suppose as we have discussed, the problem could also be solved in sequential and parallel. So if the sequential problem that is going to be solved, we could have a idea that whether the same sequential problem could also be carried out in the parallelism work, okay, in a parallel way or not. Okay, then independently invent a new parallel algorithm. So if there is a possibility for a given problem which is already going to be solved in the sequential approach, we have to find a approach whether parallel algorithm approach could also be implemented on that. If that is if we find certain sort of thing, we have to develop a algorithm in such kind of scenario. Adapt an existing parallel algorithm that solves a similar problem. If there is an already existing algorithm, we could take it, or otherwise we could develop a new one. Okay. Next, parallel algorithm complexity. So this is one of the important thing that we could observe. So there are certain sort of things which are important and associated with the parallel algorithm complexities. What are they? Time complexity, processor complexity, work complexity. So what is the time complexity? As we have discussed now, a given problem when it is going to be solved, it takes a bit of time. Okay, when we are discussing with parallel algorithms, definitely we should understand that the time required in the parallel algorithm approach should be very less. Okay, next processor complexity, that means in order to solve a given problem, how many number of processor are being involved. Okay, so if that is a complex problem, by default more number of processor are going to be involved. If that is a simple problem, okay, then less number of processor are going to be involved. That means the number of processor that are involved, that indicates the processor complexity. Next, work complexity. Work complexity is nothing but it is a product of how much of time is going to take to the solve the given problem and how many processor are being involved in the problem. Okay, so time complexity is denoted by capital T of n, that indicates, as we have discussed, execution time per run time. Okay, so that means how many time steps are needed. So when we are dividing a problem into a particular subtask, and each subtask is given to a processor, and each processor is going to execute the task in certain time steps. Okay, we call them as a unit time. Okay, so like that. Next, processor complexity, that means it is denoted by P of n. So to solve a given problem, how many number of processor are being involved. So that is nothing but called as the processor complexity. Work complexity, that is denoted by W of n. So work complexity nothing but indicates the total cost. So how we can expect the total cost? The time that is taken along with the number of processor which are being involved to complete the task. That gives us the total cost, that nothing but resembles the work complexity. So work complexity, total cost, is a product of time complexity. That means how much of time is going to take to solve the problem and how many number of processors are being involved. Okay, so next, so if we consider the same example problem where 8 numbers are being added, which we have discussed previously. So let's find the time complexity, processor complexity and work complexity. So what is the time complexity? First of all, here we have to observe how many number of steps we are going to solve this the given problem. So here we are going to solve this given problem in log n steps. So the time complexity becomes order of log n. Okay, so order of log n. In the same processor complexity, so let's suppose there are n number of processors are going to be required, then what is the processor complexity? The processor complexity becomes order of n. Okay, so work complexity, as we have got the time complexity and processor complexity, we can easily calculate the work complexity, as work complexity is nothing but that is giving the total cost, that is nothing but the product of the time complexity and processor complexity. So what is the time complexity? Order of log n. And what is the processor complexity? Order of n. So therefore the total cost, that is W of n, for the existing n number of processor which are involved to solve the given problem, is nothing but order of n log n. Okay, so this is how in a simple way we can calculate the total cost for a given problem. Okay, so these three things are being very important for us. Next, to measure the parallel algorithms, okay, we are having certain sort of parameters such as speed up, efficiency, like that. Okay, let us suppose T star of n, that is nothing but the time complexity of a sequential algorithm. That means the time taken by a problem to solve in the sequential approach. Okay, so of size n. Okay, next. Consider the time complexity that is carried out to solve the same sequential problem in a parallel approach, that is nothing but Tp of n. Okay, so how to calculate the speed? The speed, that is nothing but that gives the performance of the parallel algorithm, that is determined by calculating the speed up. So speed up is nothing but time taken to solve the problem in the sequential approach by time taken to solve the same problem with respect to the parallel approach. So definitely that should be less than or equal to P. Okay, that means what is P there? Solve the given problem. Okay, the given problem, how many number of that means process that it is going to take. Okay, so the best possible approach, that is nothing but the speed that could be carried out with respect to a parallel processor, that is nothing but equal to P. Okay, So here efficiency is nothing but calculated if you know the speed. So how many number of processor are being involved with respect to the speed, that nothing but defines as the efficiency. Okay. So these are the two parameters which are very important in order to talk whether parallel algorithms are working in a proper way or not. That is nothing but the speed up and efficiency. Okay. So why parallel algorithms are being important? So definitely as we have discussed with respect to the real time scenario, if the same task is going to be carried out by many people, for example consider one more scenario. A house is being built. Suppose there is only one worker to build the house. It takes for him nearly more than for suppose 6 or 8 months. Okay. If there are 10 people, then what happens? The construction time for the house is going to reduce. Okay. So we are involving more number of workers to complete the task. So in the similar way, to complete the task, if we are going to involve more number of processor, what do we expect? We can complete the task within less number of time. Okay. To accelerate, to speed up the running code, okay, we require the parallel algorithm. So that is one of the important thing. So providing multiplicity of data paths and increase the access of the storage element. So not only we can carry out the computation task very fast, but parallelly we can execute the task within short period of time. So due to which what happens, at lower cost with high performance we could complete the task. Okay. Solving difficult means what? Unsolved problems. Sometimes what happens, if you are going with a sequential scenario, the problem is not going to be solved with the sequential approach. So at that time we could apply parallel approach. Okay. So there are other things or other areas where we could apply the parallelism. So that means in applied physics, engineering and various other environmental issues, that means to calculate the climate conditions. Okay. So generally what happens, if how the weather forecast is being carried out, it depends on the information that is given from the satellite. Per second the satellite is going to provide 50 to 1 lakhs of images. Okay. So it takes a bit of time to analyze those images in order to predict the forecast of the that means weather. So here what happens, if you are going to carry out the task in a sequential way, what do we observe? Today's evening, if you are supposed to give the weather forecast, we could get the result tomorrow. So in order to solve this scenario, if you are going to solve the same thing in a parallel approach, we could carry out the thing very easily. Okay. In such kind of scenario we do require the parallelism. So where do we apply the concept of parallelism? Definitely in the area of science, as we have discussed, to calculate the forecast. So astrophysical modeling. So in computation, while dealing with the chemical compound, their bonding in order to solve. Okay. So we could carry out in biology, genomics. Okay. In drug design, if we are going to calculate that means the DNA representations, whatever it may be, with the parallel approach we could get the result very soon. So engineering, so to know the earthquake, okay, structure modeling, design of a combustion engine, so crash simulations, airplane designs. So engineering, we could get these results very soon. Okay. If you are going with the parallel approach. So in business, finance and economic modeling, in order to predict that means the share market, the ups and downs. So like that. Next, transaction processing, lot of web services. Okay. Search engines, in search engines what do we observe? N number of people throughout the world. Okay. Crores of people. Okay. They are going to search different required things. So in order to process them with respect to the server, definitely parallelism approach should be carried out. Okay. Next, defenses, to handle the nuclear weapons, and in cryptography, okay, we use the concept of parallelism. Okay. Parallel algorithms. So if Flynn's classical taxonomy. So Flynn in 1966, depending on the number of control units, he has divided the that means to solve a problem we require more number of processors. So depending on that, he divided the stream into 4 categories. What are they? Single instruction, multiple instruction, single data stream, multiple data stream. So here when we talk about the single instruction, that means that the architecture has single control unit. Okay. That generates a stream of instructions in the form of single instructions. So here we are having only a single control unit, that means single processor. Okay, we are having a multiple processor, that is nothing but multiple instructions. Next, single data stream. So here if we observe the concept of the single data stream, a single data stream is a single processor available which will execute a single stream of data. Okay, so single stream of data, that means a continuous flow of data could be carried out with the help of a single processor. So the same thing also be carried out with the help of, if multiple processor, we call that one as a multiple data stream. Okay, so these are the four basic divisions that flying has been carried out with respect to the divisions. Okay, so that is nothing but we could say that yeah, single instruction, multiple instruction, single data stream and multiple data stream. So every kind of approach is having its own importance. So if, when we talk about SISD, so this is a generally used serial computer architecture where single processor execute the instruction one after the other. So each instruction operates on a single data element at a time. So we could not carry out multiple operations, okay, at a time, because it is a single instruction stream. Okay, so where we are going to utilize this SISD approach, in most traditional computers like our personal laptops and desktop, we could carry out SISD, because whenever we are a single person is using or carrying out the computation task, definitely here he might be dealing with certain simple applications. So that's why SISD applications are limited to traditional laptop and desktop applications. So if you go with another approach, what is that one? Single instruction stream with multiple data stream, that is nothing but termed as SIMD. So what do we observe here? Single instruction is executed on multiple data elements. Okay, so here data elements are multiple and we are going to execute them by instruction by instruction, okay, on multiple data simultaneously. It is often used in system to design high performance tasks like scientific computations and graphic processing. So in scientific computation we require to carry out multiple computations. So in that process, what do we observe? We need to carry out the computations of multiple data. Okay, in such kind of cases it would be better to go with SIMD approach. Okay, so what are the applications where we are, or in which field we are using the concept of SIMD? That is nothing but most commonly example is nothing but GPUs, graphical processor units. So there most of the video games, there we are playing high end video games, so there we could observe the use of this SIMD. Next, MISD, so multiple instruction stream with a single data stream. That means what? Multiple instruction